Okay, this is 6.5. Graphs of polar equations are right here. Now, you might want to be familiar with what I went over in the notes, which was these six main types of polar curves that we're going to talk about. So a cardioid looks like this, inward spiral. Um, as if you look at an inward spiral, as we rotate to a positive angle here, you'll notice that my r is getting smaller. So that's why it's called an inward spiral. The outward spiral down here is this just the exact opposite. When I rotate in a positive angle direction, my r is getting bigger and bigger. And then I've got my limacon right here, rose curve, and a lemniscate, which looks like an infinity symbol. Now, I don't. I'm sure these have application somewhere. The only one I know for sure is this cardioid here. This has application in acoustics because the microphones, you'll notice, if you go to buy a nice microphone, they have different sound patterns that they pick up, and one of them is this cardioid pattern, where basically if your voice is in front of the microphone, it'll pick up all this sound, but nothing behind the microphone over here will get picked up. But we've got to try to graph these and match them to those six words. So the first one, if you go to y equals and plug it in, make sure you're in polar mode in your calculator, and just take a look at this graph. You'll see it's a 4 rose petal, so that'd be an F. And the next one is 6 theta. If you graph that, you can see it's an outward spiral. You can zoom out if you want to see more of it, zoom 3, and then hit enter, and you'll be able to see more of the spiral. Also, if you're having trouble seeing these, go to your window and make sure that, I'm going from my theta from 0 to 2 pi. I'm in radians right now, and my theta is changing by about 0.1. Sometimes if your theta step's too big, it's not gonna, your graph's gonna look funny, because what the calculator is doing is it's just graphing points and connecting with a line. And my calculator is graphing points of about an increment of 0.13. So it's going to graph, 0, 0.13 for theta, and then 0.26 and so on. And if this theta step's too big, you're going to get a really weird looking graph. Or if it's too small, it might take forever to graph all those points. Next one is 6 divided by theta. And if you graph this one, you can tell we have an inward spiral now as theta rotates counterclockwise, which is our positive. Our r is going smaller. And then next, 6 plus 12 cosine of theta gives us this. I'm going to change my window a little bit more in the positive x. In fact, I'll just zoom out a little bit. And a little bit hard to see that, but that's our limacon. So then 6 cosine of 3 theta gives you a 3 rose petal. And then the next one, 6 minus 6 sine of theta, gives you this cardioid here, C. And then the last one, I can't type in r squared, so I'm going to have to take the square root of both sides. So if I take the square root of both sides, I just get 12 cosine of 2 theta square rooted. And I can plug that into my calculator. Typically it'd be plus or, I was able to do the plus and minus here. And if you graph it, we can tell it is our lemniscate here. Okay, for the next problem then, if you graph just a regular polar coordinate r theta, and you make a triangle out of that, then this is your x and this is your y, and from that, you have the Pythagorean theorem, x squared plus y squared equals r squared. And then you also have, if you do the cosine of theta equals adjacent over hypotenuse, and you have sine of theta equals opposite over hypotenuse. Multiply both sides by r for this, and you'll have x and y in terms of r and theta as well. So these are relationships, these three, that we're going to use for these problems. The first one, x squared plus y squared, is right here. That's just r squared. So the left side of that I can make r squared. And the right side, 2x, x is r cosine of theta. So I can write this, and then I can divide out an r from both sides. Divide both sides by r, and you get 2 cosine of theta. So the a that they're looking for in this case is 2. Alright, this next one's a really tricky one to get in this form, but let's just plug in for x and y here. So we have r squared cosine squared of theta minus r squared sine squared of theta equals x, which is r cosine of theta. So I just plugged in x and for x squared here, and squared it. Now I can factor out an r squared. I'm left with cosine squared minus sine squared. And that's actually on our formula sheet. So I had to look through the identities real quick. And on the formula sheet, you'll see the cosine of 2 theta is cosine squared minus sine squared. So the cosine of 2 theta is what this is. So I'm going to write that as cosine of 2 theta. And then I can obviously now divide both sides by cosine of 2 theta. And I can also divide by one of these r's to get rid of this r from this side. So I end up with r cosine of theta over cosine of 2 theta, which is what they wanted. So a is 1 and b is 2. All right, this next one's a really long one, so I'm just going to show you my work for it here and save some time in the video. But you want to take x to the fourth and plug in this right here, and then take y to the fourth, plug in y, and then you'll get this equation right here, and then plug in x and y on the right side as well. And then we can factor out an r to the fourth, and this would end up being r to the fourth, and this would be r squared. But obviously I can then simplify those, divide both sides by r squared, and you get then this. And then, this I can factor into a difference of two squares. I can make it cosine squared plus sine squared times cosine squared minus sine squared, where this is just 1. It's a Pythagorean identity. And then this, like we talked about before, is the cosine of 2 theta. So I made that cosine of 2 theta. And then on the right side here, this is the tricky step, but I put 1/2 times 2 in front because that's just 1. The reason I did that is because this right here is an identity on our formula sheet as well. That's this identity right here, sine of a double angle. So that way I can write sine of 2 theta. So it's 1/2 sine of 2 theta, and then I just divide both sides by cosine of 2 theta here. And that gives me this, which is really just 1/2 tangent of 2 theta. So 1/2 is my A, and my B is 2. Okay, the next problem I'm going to do, I've got my 3 equations from up above, just from drawing a triangle in the first quadrant. I'm going to do 6 times the sine of theta. The sine of theta right here I can solve for. It's y over r. So I'll write y over r there. Plus 13 times, and then cosine of theta will be x over r. Now I've got a common denominator in the bottom, so I'll just add those together and make it 6y plus 13x all over r. And then I'll move that to the top by multiplying by the reciprocal. So I'll make this 22 times r over 6y plus 13x. And then I can cancel r's on both sides of the equation so that this is a 1. Multiply both sides by 6y plus 13x equals 22. Now there's my line in standard form, and I want to put it in y equals mx plus b form, so I got to solve for y. So I get 6y equals negative 13x if I move the x over, plus 22, and then just divide through by 6. And I can simplify this into 11/3. So there's my answer. Okay, the next problem, I have r equals 3 sine of theta. Once again, sine of theta I'm going to replace with y over r right from this equation. So it becomes r equals 3 times y over r. I'll multiply both sides by r. This gives me r squared equals 3y. Now r squared is right here, x squared plus y squared. And unfortunately, I'm going to have to complete the square now. So I'm going to move this 3y over and add something else to it to complete the square. That something is always b over 2. So I'm going to take negative 3 over 2 squared, which is really 9/4 added to both sides. So this becomes x squared plus y minus 3/2 squared equals 9/4. And now it's in standard form for a circle where my hk is... This is x minus h squared plus y minus k squared equals r squared, where the center then is 0 3/2 and the radius is 3/2. Okay, this next one's pretty easy. I can write this as 9 over sine of theta, and sine of theta we know is y over r right here, so I'll just replace it with y over r. Instead of dividing by y over r, I'll multiply by r over y. The r's cancel. I get 1 equals 9 over y multiply both sides by y, and you get y equals 9. Next one, same thing, it's just all algebra. So it's 2 times the tangent. I'm going to write that as sine of theta over cosine of theta, times the secant, which is 1 over cosine of theta. So this becomes 2 sine of theta over cosine squared of theta. Now I can replace sine from this equation with y over r. I can replace cosine with x over r. Then instead of dividing by the fraction, I can multiply by the reciprocal. And this is still r on the left side of the equation. So this r cancels with one of these, and I'll rewrite it now as r equals 2yr over x squared. These r's can cancel, leave me with 1 equals 2y over x squared. Multiply both sides by x squared, I get 2y equals x squared, and then divide both sides by 2, and I get my equation that I want. It's x squared over 2. All right, the next equation, I'm going to go the other way around. We want an equation with a slope of 1/5 that goes through the origin. We know that's this line. And then we can replace y with r sine of theta, and we can replace x with r cosine of theta. And the r's cancel, and I'm going to divide both sides by cosine. So I get sine of theta over cosine of theta equals 1/5. This is just tangent of theta equals 1/5. So I can do inverse tangent of 1/5 equals my theta, which is what they want right here. I'd write that as arctan with Webwork. Okay, the last problem wants to know which of these is a horizontal line. So let's just take the first one. We could graph it in our calculator, obviously, or we could take it and just do some algebra to figure out what it is in y equals mx form or y equals x form. So it's 7 over sine, because cosecant sine, and then we know that, once again, since since y equals r sine of theta is y over r. So I'm going to replace this with y over r, and I'm going to multiply by the reciprocal instead. So I'm going to multiply by r over y. The r's can cancel, leaving me with 1 equals 7 over y. Multiply both sides by y, and I get y equals 7. So there's our horizontal line. Y equals 7, we know, is just this horizontal line up here. And then the other one, it's going to be 1 over cosine, and we know that then cosine is going to give us an x value, so this is going to be the vertical line, because we're going to basically end up doing the same thing, but with cosine, which we know that is, instead of y over r, it's x over r. So when we follow the same pattern, we're just going to get an x here instead, which gives us that vertical line.